where I is I is what I call the total number of independent variables. Dimensionless, meaning when I'm done at the end, everything is dimensionless. How many terms I needed to describe the problem? And it turned out to be n minus 3. Anyone want to make a guess as to that? Where did 3 come from? 3. I start the lecture with unit quantity, primary quantities. Yes?
Number of base units.
Number of base units, which are
Mass.
mass, length, and time. 3. And that's what we're doing in dimensional analysis. So I'm going to use some grouping so that when I'm done with the entire problem, look at the physics, and stand 30,000 feet looking down. I take away all the units. Everything now is described dimensionlessly. So the mass, length, and time, the 3 variables, are eliminated. They're gone. And that allowed me to reduce the variables, in this case from 7 to 4. And that's what we're expecting. So-called dimensionless grouping that we call pi. And I know from pi theorem, nothing more. Pi theorem only tell you one number. I'm expecting 4. Okay? And you have other homework that's forthcoming that will have different variables, and you have to determine on that basis how many dimensionless group will be resulted from that. So that's just a setup. And our task to follow in the next 10 minutes is to find out how to find those pi terms. I'll do 2 of them. Your homework is to do the remaining. That's what I meant by the class 4. So the fundamental step that go next, which is very important, is to take all those variables, dependent and independent, and now replace them in terms of the primary units of mass, length, and time. And the reason that is needed is because we're going to group them so that we will succeed in getting a term that is dimensionless. So all those 3 parameters will disappear as the end result. So this step is where you can not afford to get it right, because if you have the wrong unit, it's like a dance. Start the wrong foot, everything go downhill. Okay, so the easy one of the far right is all the length. Velocity is easy, length divided by time. Viscosity is certainly not obvious, and you should convince yourself, or some of the homework will have you do this derivation, so it's to be proven by yourself as part of the homework, and you remember how viscosity is defined, and that's how you will start. Shear stress, velocity gradient, all those have to be expressed in terms of mass, length, and time. And pressure, we did it last lecture. So this intermediate step is a given. You cannot afford not to have this right. If this is wrong, then the dimensionless term will all be wrong. So I cannot stress the importance of this. So once I have that, the next step is where it becomes very difficult to comprehend, and it's a little vague. So to form those pi terms, I do have to make a decision on my dependent variables. sorry, on my independent variables on the right-hand side, I have to go from that list of 6 and choose 3. So the 6 are listed on the right-hand side. From those lists of 6, I have to pick 3 with only one caveat. All right, meaning independent dimensionally. That is where it's become hard to comprehend. What do I mean by independent Q? And I use example to illustrate that. The 3 terms that I pick on the right-hand side will later on be paired one at a time with the remaining variables, and we will show that. But right now, the decision to pick the 3 is a little bit vague. So I give you a warm choice on the right-hand side. I pick length of the pipe, diameter of the pipe, and the roughness. Is that dimensionally independent of each other? Is it? You cannot pick any 2 and obtain the third in terms of dimension. They are all length. They are all of 1 and 1 unit, which is length. They are not dimensionally independent. They're all the same. This is not acceptable. So I'm trying to use counter example to help you understand what this dimensional independent means. Another counter example is pressure, wall density, and velocity dimensionally independent? Meaning, is there a way I can take 2 of these 3 variables, combine them, raise them to different power, and get the unit of the third one? Yes, which one? How? How? Rho v squared. This combined together will give the same pressure, same unit as pressure. So this is again not acceptable. All right. So we'll come back to this a little later after you have some more homework to help digest this. This is a little hard to understand, but the choice we will make to proceed further on the right-hand side are density, velocity, and the diameter. Now, can you take any of these 2, velocity, density, and group it and raise to different power you want and get the unit of the third one? No, there's just no way. They are independent dimensionally. That's what we meant. Yes?
Does it matter if we use the diameter or if we use any terms that have that?
That's an excellent question. The answer is no. You can pick, instead of diameter, the roughness, because it's a length scale. Okay? So those are very good questions. You can replace diameter with either E or length. But traditionally, because of Mr. Reynolds, in order to get the Reynolds number, we pick the diameter. So it's by tradition. Okay? Despite this criteria of dimensionally independent. That's a very good question. So the answer is yes, it's acceptable. Furthermore, there's another choice which we will not use, but it's acceptable. Instead of density, I can actually use viscosity. But my answer of the final dimensionless plot, which I have erased, will be different. I won't get Reynolds number, I will get something else, which nobody used, so I'm stopped doing that. Right, I just go with tradition. Okay, this is a little vague and hard to digest, but I think I better take this on, and you have to just trust my work. Just basically say, by tradition, we're going to pick the density, velocity, and the diameter. So let's see what will happen when we do that. And the first one I will do in detail, the remaining one I just, the second one I'll do by inspection, and the others I want you to do it as homework. So step now 4 is to use what we have chosen. In this case, will be D to find the pi terms. Pi terms is the dimensionless term that I'm after when I'm done. Right? So how does that work? So the first term is my dependent variable, that's my first one, Q1, which is the pressure. That's what I'm paid to estimate or do an experiment to determine. So I'm tasked now with determining what grouping of density, velocity, and diameter raised to an unknown power to be determined, such that pi 1 is unitless. Can you tell me that by inspection? Yep.
Can you use delta P, or can you raise delta P to a power?
No, the reason is we are raising the power of the 3
Okay.
chosen non-dimensionalizing primitives by design. So I don't want to complicate things by raising delta P to another power. I want to keep it at 1. Yes?
Would it be 1, 2, and 0?
You are 2 steps ahead of me, which is very good. So what grouping will get delta P to be dimensionless? We just did that half hour ago. Delta P by what? Rho V squared. Now, you can put in a half by just convention. Convention, say, from Bernoulli. But I know the answer because there's someone you did half an hour ago. And just like what was said, by inspection, what is A, B, and C then? Repeat that answer again. 1, 2, and 0. Right? There was a question here? Yes?
Yeah, so what, you can pick delta P for one of these 3 values, so what would the 4th value here be?
The 4th value, there's
You
only,
had picked 3 that.
this 3 is fixed.
Right, so you can pick any of the 7, right?
You can take any of the 7 one at a time. So you cannot do it more than just one at a time.
Right, so, but what if the 3 values you pick, instead of picking density, velocity, and diameter, what if you had picked 2 values and also delta P? Well, how would you be doing this?
You can, from the setup here, at this stage, I have to choose 3 on the right-hand side.
On the right.
On the, yes, that's it. On the right-hand side, dimensionally independent Q on, I didn't say yeah, I'm sorry. That's a good point. From the right-hand side, from the independent variables, I choose 3. Leave the dependent variable pressure delta P alone. That's because that's what we're after. Right? This is a very dynamic class. And I like, yeah, question in the back?
Shouldn't the exponents be negative?
Yes. Thank you. -1. -2. Thank you. We'll show you how in a moment. There was other questions? All the same thing? Yep.
For your exponent, for B being -2, is that where you get the 1/2 from?
No, this 1/2 is not going to be obtained from dimensional analysis. Remember, dimensional analysis is all about unit. So I could stop here and maybe I should. But by convention, again, because of Bernoulli, very often this is presented with a 1/2 in the denominator. But you're not gonna get that from dimensional analysis, because it's not possible.
And, also with your pi theorem and needing three independents,
Uh-huh.
why, because your exponent for C is 0,
Yeah,
so then does your pi theorem really hold there?
yes, it can be anything. It could be 0, it could be -1, could be +1, could be 10, could be anything to be determined. It's not constrained by any mean. Other questions? Okay, yeah,
So we're finding 4 pies, right?
say again.
We're finding 4 different pies,
Let's go back when we're done.
and
This is the first one, yes.
so are those 4 pies just the ones that are not the 3 independent?
Yes, that's correct. You'll see that in a moment after I'm done with this. There will be pi 2, pi 3, pi 4, and that's your homework. Right? So let's say I cannot do this by inspection because there will be a problem in your homework that is not obvious. Right? And turns out a more rigorous, robust way to do that is to go through algebra by formulating 3 equations with 3 unknowns. And the 3 unknowns are A, B, and C. How? Well, I'm going to express them in terms of my fundamental mass, length, and time quantities. Right? So with that, I can have knowing, and then done. When I'm done, there's no unit. So mass must be raised to the power 0, so it becomes 1, and so on and so forth. The 3 equations become then mass, where I'm grouping all the terms within to mass. In case if you fail to see that, let me break it up over here. So I have mass raised to the power 0, it's equivalent to the mass raised to the exponent A, and also mass appear as unity. So this tells me A is -1. All right, then the length, and you can prove that yourself if you have problems seeing that immediately. Which has both A, B, and C in it, so I cannot solve this equation yet, because I need the 3rd equation to pose the problem, and that's the time. Which that itself tell me that B is -2, and from the middle equation, I concluded that C is 0. So this reinforced my inspection, meaning I get what I expected. And it's the same answer as I have here. So as a result, the pi 1 term, when you write it out, so from dimension analysis, all I can conclude is the dimensionless pressure term is P divided by rho V squared. The 1/2 is something else from convention, from the wisdom of Bernoulli, and it's not to be determined by this dimensionless analysis. So let me stop here and make sure you're on the same page, because the homework is going to come next. All good? Yeah, I think the most difficult part to digest is picking the 3 dimensionally independent term on the right-hand side. That will be reinforced with more homework. So here's an in-class problem. Pi 2. What do I mean by pi 2? The next term on the right-hand side of that equation, I will choose viscosity. How's that? Right? And I'm going to find a new pi term by grouping the same 3 parameters, density, velocity, diameter, now raised to a different set of exponents. So we call it D, E, and F. And when I'm done, all that will result in the pi term, and your homework is to solve for D, E, and F. Can you do that? Do you know what's being asked? Do you understand the in-class homework problem? Can you repeat what I have done for the pressure now with viscosity? And do you know what the answer is? What will pi 2 be where I have viscosity in the numerator and a combination of density, velocity, and diameter to make it dimensionless? Yeah, the inverse of the Reynolds number, between rho, V, and D. So the answer is given. You just have to prove it. You understand the problem? Any question? 2 more, and then we are done. The 2 are now pi 3, which is, take another term on the right. Now I take the length, and you're going to combine that with the same grouping, rho, V, D. And now you raise to get a different power. So I want you to work it out in a rigorous way, meaning you have to not just do it by inspection, but work out the mass, length, and time. 3 equations, 3 unknown. Yes?
How are you choosing which values to evaluate, like viscosity and length? Because you're only going to do 4.
We're going to do 4. The 4 comes about from the remaining term on this right-hand side, right? Because what I have done is I take velocity, the diameter, and the density. So I take those 3 and I say I'm going to use them for formulating my pi terms for all the remaining terms. So this now is being taken out of my function. So you take 3 and combine 1 with pressure, that's pi 1. Then the second one is with viscosity, that's my pi 2. What left then is my length and my roughness. And that's what we are doing for pi 3. So what's the answer by inspection? That should be a piece of cake. Pi 3 will be L over D. So that's your answer, you just have to prove it by solving 3 equations with 3 unknown. Pi 4, same old, same old. Now with the roughness. And then to 3 equations of J, K, L. And again, the answer, we know it. Roughness factor. Where have you seen that? What's the name of that chart that you used to solve fluid problem in pipe? Moody. Yeah, that's where it comes about. And what's the x-axis of the Moody diagram? Moody diagram, remember? What is the x-axis of the Moody diagram? Reynolds. Right here, Reynolds. What's the x-axis? What's the y-axis of the Moody diagram? No. Friction factor. We will learn later on the friction factor actually relate to pressure drop. So it's a whole big circle that you go around. And all we did today is to look at how I can simplify what appears to be a fairly complex problem, starting with 7 variables. That's a lot, right? And when I'm done, it becomes 4. That's huge. That makes my life a lot easier. And in some cases, it makes an experiment much more cost-effective. Because it's much cheaper to test an airplane model in our tunnel here in the parking lot than to actually fly it. Right? But you also learn there's limitation. And that sometimes you can get burned big time. So we need to learn about those limitations, things that we cannot match even though they're important. All right? I'm short of time to go for SP1, I'll do it next time. How's that? Yes, question?
So, is it homework to prove all three of those purchased?
Home, okay, in-class homework, let me clarify, in-class homework, yes, all three of those. So you only need 9 numbers. 3 each,
I two, pi three, pi four.
that's correct. But more than that, the numbers are the J and the K and the I and the L, et cetera, et cetera. And that's what I'm going to do.